Hi friends, welcome back to my channel on statistics. If you are seeing my videos first time, then do subscribe. Let's go to the topic. In the before video, I explain about uniform distribution, continuous uniform distribution or rectangular distribution. I will give brief introduction about uniform distribution. Uniform distribution means it has two parameters, mu of A and B. It has closure CDF. We know this x minus A by B minus A. Then it will be shaped like this. When you add two uniform distributions, then it will go to the triangular distribution. Then when you add more than 30 observation, then it will automatically goes to the bell shaped curve like this. Goes to the bell shaped curve. Now we can see what about exponential distribution and Laplace distribution in this video. Exponential distribution means, see, this is the exponential distribution curve like this, like exponential curves are like this. Okay, when you could take the CDF of exponential distribution, it will be like this. It will be going to somewhere, then it will be fixed. CDF is lies between 0 to 1. Lower limit is 0, upper limit is 1. We all know this. Where is the main application of exponential distribution means in time series and in operational research, in queuing theory, mainly in queuing theory. Lot of applications there, in reliability also, lot of applications in exponential distribution. If you take exponential distribution means, how exponential distribution work means, we already seen about Poisson distribution. Poisson distribution is arrival and survival cases. It is also same like Poisson distribution also. There is some relationship between uniform and exponential distribution. Then what is the relationship means, uniform distribution also have closure CDF and exponential distribution also have closure CDF. This is mainly used in probability integral transforms, PIT. You can generally term it as PIT. In PIT means distribution transformation from one distribution to another distribution. By assuming the uniform distribution and exponential distribution, lot of data is there related to the probability integral transforms. What is the condition for probability integral transforms means, f of h of x less than or equal to x equal to the distribution function. This is the condition for probability integral transforms. When you can transform from one distribution to another distribution, then you got the some results also, you can do it. Now we can see what is the main application in operational research. In queuing theory has survival and interval case. In reliability means consistency. We know that exponential distribution have memoryless property. Means it is consistency based. Okay, now we can see what is the definition of exponential distribution. And with there are mainly two cases are there in exponential distribution. One is lambda into e power minus lambda x. This is one type of exponential distribution. And second is 1 upon lambda into e power minus 1 by lambda x. This is also one type of exponential distribution. Now we can see a continuous random variable x is said to follows exponential distribution if for any positive value of lambda, means lambda take only positive values, not 0, not positive. Always lambda is greater than 0 and x also greater than 0. Its limits are from 0 to infinity. Okay, this is the PDF of exponential distribution, lambda into e power minus lambda x. Then for CDF, how we can got CDF? CDF means lower limit minus infinity to x, then PDF of x. Then when you perform this integration, then you can got this 1 minus e power minus lambda x. Then when you can integrate this, then you can get the PDF of exponential distribution. This is one type of PDF. Then there is one other also there, that is I have already explained, 1 upon lambda into e power minus 1 by lambda into x. This is also both cases we can use. In some cases it will be very easy to calculations, in sometimes it is also some easy. it is also some applications are there in gamma distributions also and chi-square also. See, this is the main applications for exponential distribution. The length of time interval between the successive occurrences of event follows exponential distribution. Means how it will be follow exponential distribution means successive time intervals. For examples, we have time interval 1 to 7, then we can find the time intervals, then we can get some dividers and all things, then you can get the examples of, you can refer, I think from Rothke book you can find examples, and Rothke book you can get some real life applications also with a lot of derivations. Okay, provides a number of occurrences in a fixed time interval follows for Poisson distribution. When you can refer, I think VK sorry, operation research book, then you can get all these things. Operational book, queuing theory. When you can study about queuing theory, then you can get the all real life applications about exponential distribution. You can find it. Otherwise, I will make one video for only applications on distributions. Okay, this is a big role in reliability also. These all are the properties of exponential distribution. What is the mean? Means 1 by lambda. Variance means 1 by lambda square. These all are the central moments, means which are obtained from origin. This is the relationship between the mean and variance. When you can observe, we says that standard deviation equal to the mean in exponential distribution. Here lambda square, when our PDF is like this. Okay, this is the relationship between the cumulants, means log of mx of t, moment generating function. Here we can see Pearson's coefficient of skewness, beta 1 equal to 4, and gamma beta 1 is formula is mu 3 square by mu 2 cube. When you can perform these formulas, you can get this Pearson also. Here median is 1 by lambda, and moment generating function, how we can get moment generating function means 0 to infinity e power tx into f of x dx. Then you can f of x dx, then you can perform integration, then you can get this moment generating function. For derivations you can refer books also. This is the characteristics function. This is the memoryless property, means reliability related. It is the only one distribution in continuous distributions have memoryless property. In discrete geometric distribution is there, in continuous exponential is there. It is important objective question. Okay, now we can move to the 2 parameter exponential distribution. See, a random variable x is said to be follows Laplace or double exponential distribution with parameters lambda and mu. Here lambda and mu both are the parameters. If its probability density, this is the PDF of double exponential distribution. This is the limit x takes from minus infinity to infinity. Here lambda greater than 0. Here mu less than infinity, means it will be 0 also like this. It is generally generated by like this, L of mu. This is the, and mu equal 0, you get like this. This is the application of double exponential distribution or Laplace distribution. The variate standing for the longest and lasting object out of a large number of apparently identical objects. We can see this all type of applications in one video. Now you can see what are the properties. Properties means what is the mean is mu and variance is 2 by lambda square like this. These are relationship between cumulants. Here skewness is 0. It has leptokurtic curve, and what is the moment generating function. Okay, you can refer for proofs. You can refer any book. In almost all books are proofs available. Now we can discuss about exponential families. Discuss about exponential families. Mainly exponential families. In exponential, mainly we have 1 parameter exponential, 2 parameter exponential like this. When you, how exponential forms are work, this is important. It is statistical inference. We can discuss on that video also. I will tell you what is the quick worry about exponential families. This is also, if you take Poisson distribution, in Poisson distribution e power minus lambda into lambda power x by x factorial. This is 1 parameter exponential family. How we can say that it is 1 parameter exponential family means it needs to satisfy some points, all things. Now we can see what are the points of this video. Otherwise we can discuss exponential families distributions in, see how we can say this. First we can take the log of function. After taking log of PMF, then you can rearranging the all things. When you can do the total derivation, you can get this is one parameter family. Otherwise we can discuss about exponential families in inference. Okay, then inference also you can easily to understand. Thank you for watching. If you have any queries, contact me.